So this is the article. Can you see it now?
Yes.
How to conduct. So everybody, everyone, you can get this article and in your leisure time, you can read it. It gives you an idea about how to conduct a meta-analysis. And as I've explained to you in the past, meta-analysis is not anything. I know some people, anytime people hear of meta-analysis, they put a certain fear in them that meta-analysis is like mathematical, it's difficult, so and so and blah blah blah. But actually, there is a way to go about meta-analysis that will make it easy for you, irrespective of your mathematical background or your statistical background. So I'm not going to go through all these things because we have done this before, but in doing the meta-analysis, this paper explained the types of meta-analysis. If you remember, I think I explained this to you.
Yeah.
That there are different types of meta-analysis. So one of them is called the univariate meta-analysis. And I think what I did with in my paper, the paper where I have meta-analysis for climate risk and all that, is more of a univariate meta-analysis. And then we have meta-regression. This one combines meta-analysis with regression. So if any of you have conducted a regression before, PLS, PLS, panel regression, OLS regression, multiple regression, simple regression. Even if any of you have conducted a probit, logit regression, if you have done something like that. So this type of meta-analysis combines that. So that's another. And then we have another meta-analysis which combines meta-analysis with structural equation modeling. Same. The thing I've been teaching recently. It combines meta-analysis and structural equation modeling, especially, and this is good for if you want to, if you are dealing with a lot of factors. If you are dealing with factors, maybe factors or barriers, risk, and you want to find the structural relationships between the factors, then it would be good to use this. It's a type of meta-analysis. And then we have the qualitative. Actually, what we are doing now is more of a qualitative, or what I want us to do, not what we are, even if we are not doing, like what I want us to do now is more of a qualitative meta-analysis. What is this type of meta-analysis? So in this type of meta-analysis, an aspect of it is meta-analysis. An aspect of it is a qualitative systematic literature review. The ones I have written so many papers, I've used to write so many papers in the past. The SLR, which is systematic literature review. That systematic review. It combines systematic review and meta-analysis. So what is going to what will happen? So what is going to happen is that in your meta-analysis, let's say you have 20 papers, right? Out of the 20 papers, you can have, let's say, 10 of them, or 8 of them, or 5 of them, or 15 of them, which are quantitative in nature in terms of the research design, just like how we have seen it in the papers that we have selected, purely quantitative. And then you conduct your meta-analysis. And then the remaining ones, you don't throw them away, unlike what I have done, or unlike what I did in my meta-analysis paper, where I threw away all the papers which are not quantitative in nature, but I focus on only qualitative. In this type of qualitative meta-analysis, you don't throw papers away, but rather you combine the two. You combine the two by conducting your meta-analysis with the quantitative studies or papers, And then you still write systematic literature review. So it's kind of a mixture. It's a mixture of a normal qualitative analysis. And qualitative analysis, you use something like content analysis or thematic analysis, where you do coding. You do all the coding, you do content analysis, you do thematic analysis, just like what I have done in the past. If any of you have read any of my systematic literature review, you see these things a lot. So it's a combination of the two. And that's what I want us to do. So ours will fall more into so that you don't worry yourself. I mean, thinking about, oh, the papers are not many. It seems that I'm throwing papers away. I have only 3 papers. 4 papers. I have only 6 papers. I have this. You get my point?
Okay.
So you have, let's say, 15 papers, which are relevant, but maybe out of the 15, only 5 are quantitative, and the 10 are not quantitative. So what do? Do you throw the 10 away and deal with the 5? The answer is no. Maintain or keep all of them. You keep all the 15. You can use the 5 to conduct your quantitative analysis. And then you can use the 10 to conduct your normal systematic literature review analysis, through content analysis or thematic analysis. And then you do the results, or you just present the results, and that's it. You have done it. You can still call it meta-analysis. It's acceptable. I got to know this because I was reading a certain paper from, I think, Wuni. One of my mentors, someone who taught me some time ago. Maybe some of you have know him, or you have read his papers before. At that time, when he was about to complete his PhD, I got opportunity to work with him. He taught me some things. I check some of his papers. If you check some of his papers, he has the title of meta-analysis, right? But if you really go into the papers, they are not this kind of purely quantitative meta-analysis as meta, but he rather combines some quantitative analysis. And then the normal systematic literature review analysis, the qualitative one, which is content or thematic analysis. I think I checked about 2 of his papers also. Yeah. Yeah, this is one. It's another one I'm looking for. This one. Yeah, so is everyone okay? Like, do you all get what I'm saying? Or if you have a question, you can ask me.
Yeah, I think I am getting confused with the one you just explained, the qualitative
Okay, then
meta-analysis.
ask me. Okay, so where's your confusion? Ask me, then I'll explain again.
Because I think it was explaining that unlike the quantitative meta-analysis, this qualitative focus on the findings from case studies.
Yeah,
So
a case study is a qualitative study.
yes. So does that mean that the papers, the quantitative studies we are considering, are we doing the wrong thing? I don't know.
Okay, no, we are not doing the wrong thing. What I'm saying is that, like, we are going to maintain our quantitative study, the ones that we have selected.
Okay.
But in order to beef up our sample size,
Okay.
because we are likely to be questioned.
Okay.
Even the people that I wrote that I use the meta-analysis on the climate risk, the reviewers questioned me. They said that the sample size is too small.
Okay.
Good. So how do you beef up your sample size? You can beef up your sample size by adding studies which are not quantitative in nature, but they are relevant. Remember, some of the papers were relevant, but the only reason why we took them out was that those studies were not conducted with quantitative analysis or quantitative method. If you remember, some of the papers, they were relevant. They were talking about all the things that we are trying to analyze or we are trying to work on. But the only reason why we excluded them, if I'm wrong, God's will, was it not the case? I think the only reason why we took them out was that they were not quantitative.
Yes, that was the only reason.
That was the only reason. But apart from that, they are relevant. So with start studies, according to the qualitative meta-analysis, you can still use them. That's what it means. You can still use them. This one is explanation, but I mean, I'm giving you the what the actual thing means. You can still use them. You can still use the ones which are qualitative in nature and then combine the qualitative ones with the quantitative. But when you are doing the analysis or when you are conducting the analysis, what you say is that, let's say if you have 30 papers, you have to specifically state that out of the 30 papers, I use 8 for quantitative analysis and the remaining ones for other analysis or whatever, content or whatever analysis that you did. So that's what you have to say. It's just a matter of like reporting something that maybe you put out survey questionnaires and some of the respondents are architects. Some of them are this, some of them are that, some of them are. So when it comes to the point where you want to separate the data, you can do that. You can know those who respondents who are architects and the respondents who are masons, respondents who are this, who are that. So the same.
Okay.
I hope you get my point.
Yes.
Yes. So that our sample size will be bigger. And more importantly, you, the person who is also conducting this study too, is also going to be, you are also going to be okay free so that you also don't lose or you don't throw away some important papers. Because some of the papers, even though they are, I mean, qualitative, but they contain very important information, even more than the quantitative ones.
Okay.
Yeah. They contain very important things. But the
You
only
see,
reason, okay, yeah, come back, come again, yeah. Ask your question.
I wanted to ask with the paper quality, with the ones I highlighted as qualitative studies, it means I should use the assessment tools for checking quality for.
Yeah, they say as for that, as for the assessment, whether it's qualitative or quantitative, you still have to do it.
Okay.
It applies to whether it's qualitative or quantitative, you can still use JBI to do the analysis. I'm serious. JBI has a checklist. So JBI checklist, you can use that to check. For the qualitative for JBI is 10, it's not 8.
Okay.
Good. So you can use the JBI to do this. Okay, so the difference, once again, I want to say this again, with respect to this study, for example, this study that we have submitted, the one I submitted 2 days, is it 2 days ago? Okay, today these people came back to say that I didn't arrange the authors or something. This paper will fall more into the first type. The first type is the univariate. Because with the univariate, you consider only where is the selection criteria? Yeah, so for the univariate, you only consider this. For the purpose of meta-analysis, for the the only research designs selected were quantitative in nature, inclusive of descriptive, cross-sectional, time series, and analytical articles. So this one will fall into the first type, which is the univariate. Because here we didn't conduct regression and all that structural equation modeling. So it will fit more into this. And when we use the JAMOV, you understand what I'm talking about. This will fall, this paper, the one that we have submitted, that paper, that green buildings paper for everyone, almost everyone here, will fall into this univariate meta-analysis. It's a type. But with respect to what we are writing now, I want us to use the qualitative so that we can expand our sample size.
Okay.
I hope you get my point.
Okay.
Yeah, so if there are other papers which you guys think they are important, let's add them. But when it comes to the meta-analysis, we'll focus on the ones that we have selected for the quantitative analysis, which currently is about, how many do we have? Is it 15 or 14 or 13?
12.
12, good. So when it comes to the quantitative analysis, we'll focus on the 12. But at the end of the day, the total number of articles that we are going to use for the analysis will go up. It will not only be 12, but we'll add the qualitative, the ones with the qualitative research designs. So that's it. Okay, so because we are going to do that, I want us to first focus on the quantitative one, which is the 12. So do you have the 12 articles here?
Yes.
Yes. So let's can you share your screen? Is it possible you can share your screen so that we see the 12? And now we start looking at things to extract. What do we extract?
Extract sample size.
Okay, yeah. Extract the sample size. Okay, so I think Noah, you share it with us, right?
Yes.
Okay, so you let me take you through what we are supposed to do so that we can go faster and close. And then you can do this later on so that we don't waste too much time.
Yeah. But I learned because we were supposed to do another part of the work, which was
is it this thing? The quality check.
Yeah, I think that's it.
The quality check, I sent it to you. We did it and then we sent it.
Oh, okay.
No, I sent it to your email.
Yesterday?
No, not yesterday. Like, I think about 2 weeks ago.
Yeah, yeah, and I also did a section of it. So the remaining ones I have to do it because those people who were given the section.
Oh, then I didn't know. You should have informed me so that I help. But anyway.
But I'm done. I'm done with those parts, except the ones I highlighted as qualitative.
Okay.
But I think last week we were doing additional section, which we were using Simago or something like that.
Yes. I go through is about the distant analysis, the overview, like the journals where the papers have been published.
Okay. That was last week, Saturday, last 2 weeks Saturday.
Yes. So try and do that part, okay? Yes, but I want us to move on. How do we extract the data for your meta-analysis? So you can use Excel. Okay, so to guide us, there is a paper that I want everybody to download. This is also free online. It's downloadable. And it tells you the meta-analysis. This is what I used to learn meta-analysis. When I started learning meta-analysis. This paper was published in the year 2012. And I think it has received quite a sizable amount of citations. And it teaches you how to extract data, put them in the Excel. And even it even goes ahead to tell you, to show you how to even do the meta-analysis in Excel without even going for any software like Jamovi and the rest. But to me, I think you can use it to extract your data, follow their steps to extract your data, and then use the software to help you. Why the software? Because the software make your work easy and faster. I mean, easier and faster compared to the Excel. Because the Excel you have to do this is more of like mechanical, manual computation, which sometimes is a bit challenging. But with the Jamovi, which I'm going to show you when you download, once you put it in and click, you get your results instantly. So I prefer working with the Excel sheets to extract my data. Then I will send the data into the software, and then the software will just run the results for me. That's how I prefer it. But this paper, they did so well that they teach you, or they have the steps of running a meta-analysis in an Excel sheet without going for any software. So this is a paper, everybody get it. Learn the steps, do it yourself. Just learn it. It's easy. And I'm going to show you the same thing. Even if you don't have any data that you have downloaded from any database like Scopus or Web of Science or anywhere, you can just fill in some dummy information and then run something. Oh, sorry. Let's go into this paper. So in this paper, yeah, it gives you the steps of getting your meta-analysis and then analyzing them. The first one is that in meta-analysis, there's something that we call effect size. So once again, as I said, one good thing about this paper is that it will show you the steps, and it's also show you how to get the data or the kind of information or data that you have to extract from the articles. So one of the formulas, one of the things that you have to deal with in analysis is called effect size. So how do you get the effect size? And then the question is, what is the meaning of effect size in the first place? So effect size in a layman's English is about, like, let's take COVID-19. If somebody asks you what was the extent of the spread of COVID-19 in Ghana, or what was the extent of the spread of COVID-19 all over the world, how do you know that? Or how are you going to get this? You can know this by looking at the number of people who died or the number of people who got COVID. So the extent, in other words, like, that's the name, the effect of the thing, the consequences, the impact, the size of it. I'm just trying to make it like put it in a layman's English so that to be easier. The size of it, the impact, the extent of the impact. The extent of an impact of an event or any issue. So let's say what some of these terms, that's what I told you the other time, they are from medical science field. So these things they have normally they relate it to the extent of malaria, the outbreak of malaria, cholera, tuberculosis, syphilis, HIV/AIDS. What again? So they try to look at what is the extent of the issue. So how do we know the extent of system? Okay, so according to them, for you to know the extent, so they have it here. So in your Excel, the author 1, author 2, author 3, author 4 that you see here is the study. So in our case, we have 12 papers, right? So instead of writing author 1 here, you can write the name. Let's say Noah Eta 2024. Author 2, which is paper 2, Benjamin Eta 2025. Maybe paper 3, Ama Eta 2023. So you list all the papers here. Okay, by using the first author, or if you think you don't want to write, you just write paper 1, paper 2, paper 3, paper 4, paper 5, or article 1, article 2, article 3. If you think that's going to be too difficult or it's going to be too much for you, so you list all the papers that you are using for the meta-analysis in the first column, column A. Now the effect size, according to them, or according to this article. Not only according to this article, I've also checked it somewhere. It is true. For you to compute the effect size, get to know the number of events. The number of events here can represent the number of occurrences, number of happenings, the cases. And if in terms of our work, like the number of factors, the number of barriers, the number of issues. Okay. You count them, how many? Divided by the total sample size. The end here is the sample size, the total sample size. But once again, whether it's a sample size or it's something else, you need to explain. Yeah, because nobody is going to beat you, nobody is going to do anything to you if you have good explanations to your formulas, because you are the researcher and you understand what you are doing. So it's something like if somebody use sample size like the total number of respondents, then you also have to use compulsory, and you also have to use the total respondents. That's not the case. But rather, the total represents the total of whatever, whether it is the number of people who died, or the number of factors, or the number of samples, the number of, you have to determine it and put there. Okay, so in their case, the event here, I mean the numerator is the event. In this case, the events, I think it's more, because it's a medical science, more like maybe the spread of a disease and the number of people who died, or the number of people who have contracted a certain disease or something. So that's their events. And then the outcome represents the population, the sample size, or the number of people that they sampled. That's the reason why I said it's not always the case that it should be different. Sample size is always human beings.
No, sorry. Sorry, I want to cut it. So with this effect size that we are calculating, are we going to do it separate for the, let's say, how is it? Because if we have, let's say, barriers of something, like what event are we going to, what are the events?
So that's the question. So you have to determine the event. So in this case, we have to determine what is our event. And in our paper, looking at what we are doing, I mean, what we are analyzing, we may say maybe the barriers are the event or the factors. I'm here to determine that. And you are welcome to provide your suggestions. Those of you who have been able to go through the papers.
Because last I asked about the topic, like how we are going to like write the topic, either the barriers to beam adoption or something like that. And I think before we can determine this event, we have to like know, we have to link it to the title too, or I don't know if that's wrong.
Yeah, that's true. That makes a lot of sense. But let's all try and go through the papers and determine a common thing that is running throughout the papers.
Okay.
Yeah, I think that would be better than to just say, let's look at barriers, and then you go into the papers and there's nothing like barriers there. Or you say factors, determinants, and then you check and nothing like determinants. So let's try and go through. We have 12 papers. After this meeting, try as much as possible to share it with me. I'll try and go through the papers myself and see something which is running through all the 12 papers.
Okay.
Yeah, based on that, I can, because the effect size in one way or the other is what's help us to determine what we call the prevalence rate. Like what is prevailing, what is happening, what is the common thing throughout the paper. So let's determine that. I'll take the 12 papers and share with you. But you are also all of you are also welcome to make suggestions as to what you think should be used as our event.
Please, I think Gosway want to ask a question.
Yeah, Gosway, go ahead, please.
All right. So I wanted to ask a question based on what we are discussing. So is it possible that we can have two different events? For instance, we could look at barriers, and then we could also look at maybe benefits or challenges or something.
Yeah, we can. Yeah, it's possible. We can do that. But the only issue is that because you cannot mix apples with oranges, it is better you then when you go further. In that case, when you can do something like called the pool data, like where you put all the data together, whatever they are, whether apples or oranges or whatever. But when you move forward a bit, in order to help your readers and your examiners, you need to separate the data. And then now concentrate on the benefits. And then also do a separate analysis for the challenges. So that anybody who will read your paper will know that, oh, okay, so this is for benefit, this is for challenges. Okay, that's what we were trying to do with this thing. But I think I later find out that we didn't do that. I don't know why we didn't do. I don't know what happened. I'm talking about this meta-analysis paper that we have submitted. Because initially, I remember we said we were going to separate the barriers from the factors. But what happened?
So that was how come we got the developing countries. We settled on the developing countries and then the developed countries.
The subgroup.
I don't know if you could see. Yeah, the subgroup analysis.
Oh, okay, yeah, okay, they are here. Yeah, good. They are here. This is so Noah. This is what. Oh, is it Noah or God's way? So this is the thing. So initially, we put the papers together, whether they are barriers or drivers or benefits or whatever. We put all of them together. Then when we got to this subgroup analysis, we separated. We did the analysis only for drivers, and then we did only the analysis for barriers. So when you do it this way, your readers will understand that, oh, okay, so this is what is happening to the barrier, this is what is happening to the factors, the barriers, this is factors. So we can do the same for this one. But before we can do that, let's all try and go through the papers and get to know the common thing running through all the papers before we select. Because I think I also did some analysis some time ago, and then I started by saying maybe I think the barriers or something. But when the papers I selected, when I started going through the papers, I didn't see barriers. So if you don't see barriers, what do you do? Then what will happen is that you have to take the paper out. So you need to be also be a little bit careful so that you don't end up throwing all your papers away. So first, determine what you want to run. That's my suggestion. But the thing is that in many papers and many analysis, what I have seen is that they rely on something like relative importance index, RII, or they rely on mean score instead of taking the number of barriers, the number of factors. They rely on what is the mean score from the paper, and then they will use that to represent the effect size. So they will not go and they will not compute. They will not waste time going to compute. They will not waste time going to find the event, sample size, outcome, whatever, and then come and event, sample size, and then compute the effect size. They will not do that. But what they will do is that they will just go into the paper, look for something like the mean score. And the mean score will be used as a representative of the effect size. Or they can use something like the standard deviation. Or they can use something like relative importance index. Or I've also seen a place where they have used the AHP scores, analytical hierarchy process score, or they can use the fuzzy score as the effect size. So once again, the computation of the effect size or the dissemination of the effect size, it depends on you. So we have to determine. That's why when it comes to some of these research, this thing is all about your interpretation. Nobody's going to fight you. Nobody's going to tell you you are wrong, especially when you have presented a good case. Nobody's going to fight you. But people will start fighting you when they read your paper, and the paper, you don't see the head and tail of the paper. The explanation, the formulas. That's when people are going to have issues with you. So that's what you have to do. Okay, so in our case, once again, I want to say that I think we'll meet. I want us to meet on Friday. When we meet on Friday, by Friday, we should all come. When we come, tell me about what we should use for the event. As for the sample size, it's easy to determine. Because for sample size, if we don't want to worry ourselves, we can just use the total number of respondents. Or we can use maybe the total number of factors or the total number of barriers. And so the sample size is easy to determine. But the main issue is the event. The event has to do with, should we go for barriers, or we should go for factors, or we should go for benefit, or we should go for risk? What are we using for the event? We need to determine that. Okay, good. So once you have, let's assume here we have event, and we have our samples. What do you do? What you do is that you divide the event by the sample size. So here, 404 divided by 2002 will give you this. And that's what we call the outcome. The outcome here is the same as the effect size. Column D is the effect size. So you do the same thing for each of the papers, till the end. Now, what do you do next? So that's the step one. Are we all okay with the step one? Is everybody okay with step one? Is there anyone who has a question? So calculating the outcome, which is the same as the effect size. So column D is the outcome, which is the effect size. That's event divided by the sample size. Now let's go to step two. So what do you do next? In step two, you compute what we call the standard error. And that standard error will follow the outcome column. So that will be the column E. From column D, you go to E, and that's standard error. Great. So how do you compute the standard error? To compute the standard error, you have to find the square root of the event divided by the sample size. Or you can just divide the effect size by the square root of the effect size multiplied by the sample size. Anyway, this looks some way, but when you are using Excel, it's easy. Okay, to make it easy, use Excel. In the Excel, just type anything in column D. Column D is the effect size. Then you click on divide. Then you bring in square root of. Anyway, I have some of the, I have some of the Excel this thing there. Meta analysis. What can I do? Let me check. So this is what I was talking about. So this is the. So how did we get this? Or how did I get the effect size? I divided the article 1 events. This is the number of factors identified. Divided by the sample size, which is 60. And that gave me this. And once you do one, you can drag it and to do the same. You do the same for the rest. Now we come to the standard error. So you take the effect size, which is what? 0.0888883333 divided by the square root of the sample size times the effect size. This one, as it's shown here. So just follow the steps. This. You follow this. You get it? Or you can use in any of these to give you the same answer. There's nothing, you won't get anything different. You click on it to give you this, and you drag it down. You get the results. Now let's look at the next step. So that's the step for standard error. I know people who just do this and that's the end. Some people will just compute. I have seen papers where people just computed the effect size and the standard error, and that was the end of their meta-analysis. They have conducted meta-analysis and they are right. So you don't have to do everything in this paper. You can get to a certain point and stop once you get what you are looking for. I've seen papers where they did meta-analysis, they explain only the standard error and the effect size, and that was the end of the meta-analysis. Once you get what you are looking for, you don't have to put all the steps in your paper. Now let's go to step 3. So step 3, what do? You compute what we call the variance. Okay. The variance, what is the difference? It's help us to know the differences in the studies and then the data. How do we compute that? The variance is the square of the standard error. That means the answer that you get for this, or the results that you get for the standard error, you just add square, you square it. So let's do one. So this one is the standard error, then square. In other words, multiply the same thing twice. Then you drag it down. So that will be our step number 3. Now let's go to step 4. In step 4, you compute what we call individual study weight. The articles that you are using. So here we have, in this example, we have, they showed us 10. I use 13. But I think this article, they use 10 or so. 10 articles, yes. So these 10 articles, we want to know their weight. When we say weight, it's the same thing that we do in fuzzy, the weighting function. What is the weight? The weight simply represents the contribution of a factor, of a study to something. Like if you take what? Like let's take everyone here. If somebody asks you, what is your contribution to Ghana's development? We can quantify that. Or let's put it this way, what is the contribution of cocoa to Ghana's GDP? We can quantify that. What is the contribution of gold to Ghana's GDP? We can quantify that. We can know the weight. The contribution of cocoa, gold, diamond, bauxite, oil. We can get the percentages, and we know the percent. Actually, we know the percentages of all these minerals to Ghana's GDP. So the same thing applies to weight. So if you take each study, what is their weight overall? What is their weight towards this analysis? How do you compute that? Computing individual studies weight. Okay, I think Benjamin will remember this because we did this fuzzy, and all that. So, who again? Is there anyone here who has used fuzzy? Oh.
Yeah, I think I did the AHP.
AHP, good. So in AHP, you saw weight, right?
Yes.
So it's the same idea. So how do we compute the weight? Very simple. We must weight each study with the inverse of its variance. So here we'll find the inverse. The inverse of the variance, which is in step 3, will become the weight. So what is the meaning of that? So this resource, you just use 1 over this resource. And what is the 1 over this resource? Remember this resource, which is the variance, it was the standard error, the square of the standard error. It was the square of the standard error. Do you still remember? The square of the standard error. The square of the standard error. That gave us the variance. And it is saying that we have to find the inverse. The inverse means 1 over the variance. 1 over the variance. Good. So what you have to do is that when you come here, as I've shown you, 1 over the variance, 1 over f. That's why I've put the formulas at the top. 1 over the variance. Okay, so 1 over the variance. 1 over. So I will give you the results. So that becomes the weight. Any other step? Now, step 5, it says you have to compute each weighted effect size. Now we know the weight. So it follows the same thing as AHP and FASI. Remember when we did the FASI, those of you who did FASI and the AHP, when you have the weight, you have to multiply the weight with what we call the membership functions, or the membership function, to give you the weighted values. It's the same idea. So here we are going to multiply the weight by the effect size. We have already computed the effect size in step 1. Don't forget. In step 1, that was the first thing that we did, the effect size. And now we have the weights. So what do? We multiply the weight by the effect size. And if you are going column by column, this should be easy. So if I take the weight, for example, if I take the weight for study 1 or article 1 is 720. I'll multiply it by the effect size. And that will give me the weighted effect size, which is 60 in this case. You do the same thing for all. I will not do this because I prefer using software. Normally, when I come in the software, the most important things that we need, which I'm going to take you there, is you have to get to this. Once you get to the that's the reason why I said that most people or most studies, they get to only step 3, and that's the end of it. They don't continue. The reason why they don't continue is that if you don't want to use the this Excel spreadsheet to do the meta-analysis, then just stop at step 3. It's okay. Because the remaining things or the other things that come after, like the weight, the weighted effect size, and other stuff, they are taking you to a point where you can determine what we call the Q, the I of the I square, which is the heterogeneity, and all that, which the software can easily help you to determine these things. Like when you could just put the data in there, you click, and then it will just give you the results instead of doing all these computations and getting confused. Like we do all these and it's like, hey, this mathematical thing is so difficult. What is this formula? This, that. You don't have to worry yourself with that. And even the forest plot and all that, you don't have to do all this, because this meta-analysis, once again, as I started by explaining it to you, they designed this paper to support people who don't have any access to any software. And the only thing that they have access to is Excel spreadsheets. And those people, they still love to conduct meta-analysis. So what should they do, or what are they supposed to do? So they designed this paper to support those people so that they can still conduct meta-analysis in a Microsoft Excel spreadsheet without going to purchase a software or going to look for a software. For those of us who have access to software, there's no need for me to go through all these steps. The most important thing I need is, when I'm using a software, I need my effect size, I need my standard error, and I need my variance. These are the most important things that you need. Once you have them, the software will run the rest. Okay, good. So for the sake of time, I will leave everyone to just take this paper and just do it yourself, step by step, because if I'm going to do this, I personally don't want to do it. What do you recommend? Should I do it? No, I shouldn't. Yeah, because they are self-explanatory. They are not difficult. You just follow the steps and then you do it in Excel. So without wasting time, I want to take you to this. I want to show you a certain software which is called Jamovi. So everybody download this software. Yeah, but the remaining part, if you want to do your meta-analysis in Excel, follow the remaining steps. and they are not difficult. You can do it in Excel, right? But my issue is I think I tried to do it some time ago in Excel, and that whole thing became messy, and I was not happy with it. I decided to look for. So one thing, if you have Jamovi, you can use it to do it. If you have Stata, you can use it to do it. And you also have, I think even SPSS, you can use SPSS too. But I have not used SPSS before, but I've used Stata and Jamovi. So the software is called Jamovi. Jamovi is free. Hello, are we all here? It's free.
Yes, Doc.
Yeah. Yes,
So
please.
download it and put it on your machine. And I'm going to show you other benefit with Jamovi. So I have my Jamovi or Jamovi or whatever you want to call it. Depends on whatever you want to say. So I have a copy of it on my laptop. Jamovi is not only used for meta-analysis. Actually, it's used for other analysis like regression, factor analysis. You can run all that in Jamovi. Okay. Let's try to open. Great. So this is a Jamovi. Once you download, so you have to come to their website, download it free of charge, and install it on your machine. Okay. So once you install it and open it, to show you something like this. Now, what next? That's the most important question. The most important question is to fill this thing with your information, which in this case, your data. As I told you, the Jamovi is interested in, and almost all the meta-analysis softwares, they are interested in these things. One, the study, the name of the study or the article. The name of the study or the article. And then, in this case, the event or the prevalence, the sample size, the effect size. Actually, the two of them, which is the event and the sample size, they are represented by the effect size. So in a situation where you have the effect size, there's no need for you to put into your software the event and the sample size again, because they are represented by what? The two of them are represented by the effect size, because we get the effect size by dividing the event by the sample size. So if you have the effect size, there's no need for you to put in event and sample size. You don't have to do that, because it's more like a repetition. People say it's what, tautology or something. I don't know whether it's a good English. It's a tautology, repetition. Yeah, so I'm going to show you what you need. So one, you need a study. So you copy the study. The reason why you need a study is because when the thing come out, so in my first column, I'm going to paste the study here. One good thing about the Jamovi is that it gives you the opportunity to name the column. So I will name the column the study or the articles or whatever. If you want to put articles, study, papers, whatever you want to put there, but I want to say, so I've described this. And then it's even give you the opportunity also to know the measurement scale. Remember, I don't know whether I have done this with you, but I have explained the measurement scales in statistics or in research. We have nominal scale, ordinal scale, we have the ratio scale, and then we have the interval scale. So you need to specify what this is about. In this case, this is just an ID. This is not, it doesn't fall into measurement scale and all that. Now, the next thing that I want to copy and paste here is my effect size. Very important to me as far as this analysis is concerned. So I'll bring them here. And this effect size, I need to also, once again, so you click on it, give it a name. I'm going to set the name of it. And then you need to help us to know, is it a nominal, ordinal, or continuous? So we can all see that this is more of a ratio or continuous scale, because it has ratios. I mean, it has decimals. This is not ranking. This is not nominal. Nominal is more like male, female, whether the thing is blue or black, Ghanaian or not Ghanaian. That's nominal. So I have my effect size. What next? I also need my standard error. Anyway, let me copy the two so that we don't waste too much time. I need standard error, and then I need the variance as well. So I'm going to copy the two and put them into the, and then also name them. So this is SC. Remember, the SC represents standard error. Yeah. So don't forget. And then this is my var. Remember, the var means variance. Great. Now I have this. So what next? So this is where, that's why I said I don't want to continue. Because if I continue, well, it's going to take our time and so many other things. So what, I mean, instead of computing this in your Excel and computing this in step 6, 5, 6, 7, 8, 9, and then even determine the, it's your, the summary model. Is it effects, fixed effect or random effect? Instead of doing all these things manually in your Excel, the Jamovi will help you to know all that by even telling you whether it's effect size or fixed effect or random effect or whatever. Good. So you have this information. What next? The next thing is to analyze. So in the analysis, are you going to run factor analysis? Or do you want to run frequencies? I mean, you determine. Okay, the kind of analysis that you want. Do you want to run regression? So correlation, all that can be run here. Can run correlation matrix. For example, I'm just saying. And one good thing about the Jamovi is that once you put a thing there and you run, it will give you instant results. That's the reason why I said it's good to use the software. And it even asks you the type of correlation that you want to run: Pearson, Spearman, Kendall. Okay, you can change the significance level, plots, hypothesis, blah blah blah. Just an example. Do you want to run ANOVA or Cusco-Wallace? One way ANOVA or Cusco-Wallace. So these are some of the, and then do you want to run a t-test? So that's one good thing about it. But that's not what we are interested in. What we are interested in is actually to run meta-analysis. And in meta-analysis, we have things like effect size, sample differences, standard errors, mean differences, and the rest. So all these are for meta-analysis and come to measure. So you see the meta-analysis types. Once again, I mentioned something and I want everybody to take note. Meta-analysis come in different forms. It's not always the case that you have to run effect size, and then the variances and the standard errors. You can even run correlation. You can run regression. Remember, we saw the type of meta-analysis, which is regression, meta-regression analysis. You can even run structural equation modeling. It's a type of meta-analysis. You can run correlation. It's a type of meta-analysis. And the rest. So what are we interested in? So you select the type of meta-analysis based on the information that you have. For example, if I want to run mean differences, that means I need to have all these, like group 1 sample size, group 2 sample size, group so and so. And then I need to have a moderator, steady label. So the type of information that you have will determine the type of meta-analysis that you have to run. That's what I'm saying. Okay, so here, looking at all the ones here, the one that is like suitable for our work will be this, because this is what we have. Okay, there's something I think I did wrong. I have to go back. It's saying that I have to give this one a better label. Instead of making it ID, it should be like nominal. A type of studies. Okay, so let me go back. You click on this, effect size. Now let's put it in. So you put it this here, and then you just click this. It will move the studies, the effect size. Now, two things. Do you want to run a variance or SC? It's up to you. You can use the standard error. You can use the variance. Let's use the variance. And then do you have a moderator? If you don't have it, that's okay. But the good thing is that whilst you are filling in these things, the Jamovi will also be doing the analysis and putting out the results out for you instantly, a kind of real time. Once you put it in there, the results will just come out. Can you see that? So here we have our 13 articles, and the results is showing that it's good, that the results fit more into a random effects. And I think it's because of the sample size. Yeah, but later on I'll check. The random effect is better. The estimate, standard error, z-score, our result is significant because the p-value is less than 0.01%, and the rest, which I'll explain on Friday. What is the meaning of the I? The heterogeneity. What does it mean? Here we have 97.39%. H square, this. And then when you come down, we have the forest plot. So here, instead of, remember, I told you if you were to, we can still do the forest plot, but if you were to do it in Excel, you have to do it manually, and I need to take a long time, draw this one will not fit, put it here, this, that, change this, calculate that. It's a long process. But with the Jamovi, it will automatically run it and give you the result. So we have this forest plot. And then you interpret, which I'll go through that with you on Friday. We also have the publication bias, and then the final plot as well. And other analysis like the equivalence test plots and the rest. Okay, so yeah, that's all that I want to show you today. We'll continue on Friday. Friday, when we meet, we'll go through this, and then I'll also show you what we call the subgroup analysis as well. Yeah, anybody with a question? Time is up.
Okay, Doc. So I've sent you the 12 papers, and it includes the results from the JBI check list.
That's okay.
Yeah. Also, we have sent you the impact factor analysis, the one we were computing last week together. So maybe you can continue from there.
Okay, thank you. Is there anyone who has a question or something before we go? No one? If you have a question, you'll mute and ask, or you have to talk. Okay, if nobody has a question coming, thank you very much. We'll meet Squirreling on Friday to continue. So Friday, we'll extract some data based on the common thing running through the papers. And then we'll put them together, bring them to the Jamovi, run the results, and then we move from there. So thank you for coming. See you on Friday. Bye-bye.